Okay, I'm gonna go through how to make a bar chart with point count data that has distance sampling with it. And we're going to be doing our bar chart. We're going to be comparing habitat types. You're going to survey 2 habitat types and then generate a bar chart with error bars. And we're going to go through that process. The process requires a bit of data manipulation because you have to enter your data differently for the habitat survey and for the point count survey. And so what you end up with are 2 worksheets in Excel that don't really match up. And there is a purpose for that, and that's really quite often what has to happen in studies is that you have data sets that don't quite align, but they contain information that is linked, okay? And so here is the data file, a data file for a point count with distance sampling. And what you'll notice is each row is an observation of a species, and then there's information about that species, including how many there were in that survey together, okay? And also what point they were at, their distance from the observer, etc. So this is organized by observations. In a lot of data sheets, you'll have the data organized by samples so that each row is a sample. And that's going to be the case with habitat data for this survey. You will have a plot, and then there might be some categorical variables, ways that you classify that plot or that point count. And then there will be a series of measurements, such as canopy cover and numbers of logs and numbers of standing dead trees that will be added as columns to this data set. But your unit here for each row is a plot. Okay, so we need to get these data aligned with the point count data. And we can do this pretty readily using a great option in Excel called pivot tables. And so to make a pivot table is a means of reorganizing your data in Excel. To do that, you select your entire data sheet. And you can do that by selecting the upper left corner. You click Insert, and you select Pivot Table. And it tends to show, it shows you the range of data that's been selected. This is the entire sheet. And it asks you if you want to do it as a new worksheet, which is yes. So I want to reorganize that point count data that had plots occurring, the same plot listed numerous times. I want to see a summary data set of the plot and the total numbers of birds observed in that plot. And so I'm going to take plot and I'm going to drag it into this field called rows. I want my rows in this data set to be the plots. And here are my plot labels or my point counts. And then what I want is I want the cluster size. So this is where I counted how many individuals that were moving as groups or as single individuals around. I want to have that be summarized by plot. And there we go. Now, when I drag that count field, when I drag that cluster field down into the values square here, it by default summarizes it by the count of cluster size. And the count of cluster size is what the pivot table did is it looked at how many times A11, how many times there were count cells for A11, and is listing the number of cells that were basically labeled as A11. It's not actually summing up the numbers of individuals, okay? And so I'm gonna make sure that this value is a summary. And so I select that tab there and I select value field settings. And I'm gonna select, when this menu pops up, I'm gonna select the sum option rather than count. Click OK. My numbers didn't change a great deal because most of my cell counts, most of the birds I observed, I only observed as a single individual in a survey, but a few of them would have changed. Okay, so now I have this summary data that I need. So now I have this summary data set of plots with the sum values of numbers of birds counted in the plots. And I can take that data and I can paste it into the habitat spreadsheet. Or I can make another worksheet and add it in there. Sometimes that's the better thing to do. For sake of time, I'm going to just add it to this habitat spreadsheet. And you can see, okay, now we have plots and we have abundance. And I'm going to label these too, because I just want to make sure I don't get things messed up. So the next thing I do is I look to see if my plots are aligned. So this is A11. Okay, it was a conifer plot. This is A11 with the abundances. C11, conifer, oak B5. Okay, so what I'm saying is these plots aren't lining up. And one thing I do know is that in pivot tables, these plots, when a pivot table is generated, it will organize the plots in alphabetical order. If it's numeric data, it will organize it in numeric order, from smallest to largest in alphabet from A to Z. So I should be able to take this data here and I see that this looks like it doesn't totally match up. Let me get rid of this here. And I am going to sort the data. And I'm going to sort it by plot from A to Z. And now when I check to make sure that these plots and their habitat designations and the plots with the counts are all lining up, I see they are. So that's a good thing. Great. Okay, now my data are all aligned. I'm going to get rid of this extra column of plots. And I have the habitat type in my abundances for each plot. I'm ready. I'm getting to the place where I can make a bar chart. Now, before I make that bar chart, I want to make the bar chart represent average abundance in the habitat. And my sampling unit for calculating average is going to be the point count. In this case, I'm calling it a plot, but it was also a point count. And so that's how I get my averages. So I can't just total up my abundances. I have to get an average value for each habitat type. Now I can do that by sorting this data into habitat type, and then I could use some functions in Excel to generate a mean value. But I can also use pivot tables again and do this very easily. So I'm going to insert another pivot table. And this time, instead of plot, I'm going to have my rows be the habitat type and my values be abundances. Now again, it by default did a count of abundances. It was really just the count of the cells in conifer and hardwood. So I want to this time, instead of summary, I want to get the average value for conifer and hardwood. And there we are. So I'm going to take this. And I'm actually going to start to label this because this is going to be useful for my bar chart. And average mean abundance. Now I can start to make a bar chart. I can highlight my habitat values. So each habitat is going to be a bar. And then these numbers are going to be the height of my bars. And I can select insert. And I can select a bar chart, or I can go into recommended charts. And the recommended chart is a bar chart. Okay, so there are more birds in hardwood than conifer. Well, we don't really know. And so for those of you who have taken some statistics, you know that the missing information here is some estimate of variation around this mean. And there are a variety of ways you can estimate variation around the mean. But a very common way is to get your mean and then look at the individual differences of the values from the mean. Square them, and then you can do a variety of other calculations to get values such as standard deviation, standard error, and 95% confidence interval. Those are the most commonly represented estimates of variation around the mean. And know that when you're reading scientific literature, if you're seeing a bar chart like this that's supposed to be representing means, you should be suspicious of it because it has no estimates of variance on it. So you really can't tell what the differences are. Sometimes there's so much variation around these means that the error bars are huge, and you just would need more sampling, or there's too much variability to really detect a difference. And so Before I do that, I'm gonna make a chart title. Average abundance say error bars, and then I'm going to say X for now. Change my font. Yeah, we have a chart title. So now I want to generate some error bars. And there are some pretty straightforward ways to do this. I'm using the pivot table. If I go back into my pivot table and go back into my value field settings, there is an option for standard deviation. So I can generate a standard deviation just like that for conifer and for hardwood. I'm going to call this standard deviation, STDV. And when I go into this chart, there are these options that pop up here. There's a plus sign you can see on the right side, and I'm going to select that. And you can select error bars, but don't select these default error bars. They don't really match up with anything in your actual data set very well. It's generating some kind of error between those two values there. So you want to go and hit this arrow. And so when I go into error bars, it'll even say standard error, percentage, standard deviation. You don't want to select any of these defaults because you're making these calculations from a pivot table, not from the raw data itself. It's not going to be correct. And so it's really best to generate your own error bars. And so I'm going to select more options, and you can, then I'll select error bars for top and bottom, and I'm going to select custom. And so you can select a range of data that represents your error. And so I've selected these two fields for standard deviation, and I select it twice for my top error bar and my bottom error bar. And now I have error bars that represent one standard deviation from the mean. And so if I could stop right there. So you can stop right there, represent standard deviation. That's fine. For people that want to make different kinds of error bars, you can continue on. Okay, so this is how you would make a bar chart with error bars on it. And you can see here, I can actually start to look at how much these error bars overlap and get an idea if there really are differences between conifer and hardwood. Now, if you want to just do that, you can do this. But if you want to actually get a better idea of, you can generate error bars that you can look to be overlapping or not overlapping. And if they're not overlapping, you're really pretty confident that there are differences. Listen on, because there's a couple of other steps that you need to take to get those kinds of error bars. And those are called 95% confidence intervals. So from that data, you need to, the next step is to calculate standard error. Standard deviation is an estimate of variation around the mean between the samples, and standard error is basically an estimate of how the mean might vary in different scenarios. It tends to be a smaller number than the standard deviation, and you need to calculate standard error to get a confidence interval. And standard error is a pretty simple calculation. It is the standard deviation divided by the square root of the sample size. And so first we need to know what our sample size is. We can use our pivot table again to do that. And so here we can actually pull this value out, and we can simply plop in plot. And we can count up the plots, because this is just counting the number of cells, the plots that were conifer and the plots that were hardwood. And so our sample size in conifer was 30, our sample size in hardwood was 17. So now we have the information to get a standard error. So to do that, I'm going to enter a formula. I'm going to start with the equal sign, and then I'm going to select the standard deviation, and then I'm going to divide it by the square root, and I have to type in some code for that. It's SQRT, and then type in 30. Okay, that's my standard error for conifer. Now I'll do this again for hardwood. Equals standard deviation divided by SQRT 17. Okay. Now, sometimes I do my, I think it makes any difference, but sometimes I add some extra parentheses just to make for sure it doesn't make any difference. So those are standard error. Actually, it's very common to represent error bars as standard error as well. Okay, I'm going to take that one additional step and do 95% confidence interval. So you say 95%. In a 95% confidence interval, you can calculate for this kind of comparison using what they call a t-table, or you can use some general rule of thumb. And that is that in a t-distribution, so it's a distribution that is somewhat similar to a normal distribution, but it's accounting for the fact that you've collected a sample that's not the whole population. In one of those distributions, the 95th percentile, so if you think of a bell curve, something like a bell curve, and you're thinking of the observations that are falling within at what shape of the curve you have 95% of your observations. The 95th percentile is 1.96 from the standard deviation. So sometimes people just double the standard error because it's very close. 2SC is pretty close to a 95% confidence interval. But to get a little more closer to get closer to that, most people type in, multiply 1.96 times the standard error. Oops. Okay. Looks like I typed it incorrectly. Equals 1.96. 1.96 times G4. Yes. And then this equals 1.96 times that. Okay, so those are my 95% confidence intervals. And now I can make error bars with those instead. And so if I go to, I think I can even go into my error bars. I'm going to go to error bars again. I'm going to do more options. And I'm just going to go back again down to custom and specify the values under 95% to be the values I want. So now let's look at these. Okay, we actually see some very significant difference here. Not very, there's no way to say for sure because we haven't run a statistical test, but let me enlarge this graph a little bit so you can really look at this. If you were to line up a ruler with these error bars, you would see that they don't overlap. So that means that this mean there's a 95% chance that the mean falls somewhere between this lower bound and this upper bound of this error bar. Same with this one, okay, for conifer. So conifer plots had much more, or hardwood plots had much more variability in them than the conifer, but still they had higher species counts, even accounting for that variability. So that's how you do a bar chart with error bars.